Good morning, students. Yesterday we were looking at elements, and in that class, I defined elements as a pure substance which cannot be broken down into smaller substance by chemical means. That yesterday we were looking at the first 20 elements, and I promised you today I was coming to give us a chart that has the first 20 elements. Although we have 118 elements in existence, but today we shall be looking at just the first 20 elements using a chart. And that chart is what we call periodic table as a topic today. What is periodic table? Periodic table is a chart that shows the arrangement of chemical elements based on their atomic number in organized manner, in a pattern. And that is what we shall be looking at today, periodic table, that chart that shows the arrangement of chemical elements organized in a better manner and using atomic number. Today, I would want to give you a brief history of scientists who contributed to classification of elements in the periodic table. Among them, I will talk about two scientists. One is Mendeleev, who created periodic table based, based on atomic mass. Yes, that was what he did. He created the periodic table. He classified elements into the periodic table using increasing atomic mass. He also left a gap. He left a gap that more elements will be discovered, and when they were discovered, they fitted it into the gap. He left. Another person came and modified or improved it, and that is Henry Moseley. He came and classified elements in the periodic table based on atomic number instead of atomic mass. And that is what we have today. That is what we are using today, based on the classification of Henry Moseley. So in this periodic table, we shall be looking at two things: group, and then period. Group and period. What is group? Group is called vertical column. And what is vertical column? By the time you look at the chart here and you look at it from top to bottom, and we have 8 of them here. Though in a modern periodic table, we have 18 groups. But just like I said earlier, we shall only be looking at the first 20 elements, and that is why we have what we have on the board. So here we have 8 groups. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 of them here. And then what is the pattern to which these elements are classified on the group depends on the valence electron. What does it mean? Let's look at the first element in group 1, which is hydrogen. The electronic configuration is 1. That of lithium, the atomic number is 3 and the electronic configuration is 2, 1. That of sodium in group 1, the atomic number is 11. The electronic configuration is 2, 8, 1. So if you look at this, you have one thing that is common, and that's the valence electron. What is valence electron? Electron at the outermost shell. And you can see 1, 1, 1, and that is the pattern to which these elements in group 1 are classified. The same thing is applicable to group 2. You see 2 electrons at the outermost shell. In group 3, you see 3 electrons at the outermost shell, and it goes like that. So now let's return to period. Period is horizontal row. Horizontal row means when you look at the chart from left to right. So you have 7 periods here. And the classification is based on this number of shells. Let's look at period 1. Period 1, hydrogen. The number of shells is 1. Period 2, lithium, 2, 1. Now the number of shells in period 2 are 2, and every element with 2 shells are classified on period 2. The same thing is applicable to period 3, and it goes like that. Do you understand now? So the classification based on period is the number of shells. If you have 3 shells, then if an element has 3 shells, then it will be on period 3. And that is what we shall be looking at today. By tomorrow, I will